Okay. I think it's a good time to get started. We have a lot to get through, so we'll just let people trickle in, and we'll let our helpers admit people as they come in. Okay, so let's jump right in. So thank you for joining us for today's webinar for the New Energy New York webinar for the round 2 of the Technical Assistance Vouchers Program. The New Energy New York initiative is powered by Binghamton University through the Office of Entrepreneurship and Innovation Partnerships. And my name is Emily Marino, and I'm the Senior Program Manager for the New Energy New York initiative. So before we begin today's presentation, I just have a few housekeeping notes. First, if you are not muted, please mute yourself so that we can reduce feedback. This session is being recorded, and you'll receive an email with the recording and the presentation slides in your inbox after the event. It might take a day to get that recording uploaded, but you will receive it. We will also have time at the end for question and answer, but please put your questions in the chat so that we can get to those later on, because we have a lot to cover today. So first, I'd like to introduce our speakers. Today, I'm joined by 5 presenters. Matthew Gander, who is the Director of the Battery Development Center at RIT. Martin Ploss, the Director of Energy Storage Testing at the Battery Development Center, also at RIT. Hugh Zhu, the Battery Development Manager at the Northeast Center for Chemical Energy Storage, NEXIS, at Binghamton University. Donna Howell, Director of Industrial Partnerships at the Cornell Center for Material Research. And Ron Olson, Director of Operations at Cornell Nanoscale Facility. I'm also joined by our New Energy New York Administrative Assistant, Samantha Lane, who will be helping to facilitate this presentation. Our presenters will be discussing their facilities as potential service providers under the voucher program later on in the presentation. So without further ado, let's jump right in. Okay, so if this is your first event with us and you're not familiar with the New Energy New York NENY program, NENY is building a nation-leading ecosystem in upstate New York, which is designed to advance the domestic battery and energy storage industry. This initiative is led by Binghamton University and has brought together a cross-section coalition of partners to support research and development, innovation, technology translation, and workforce development. The NENY initiative is supported by the U.S. Economic Development Administration and Empire State Development. Through this initiative, we aim to create an innovation and manufacturing technology hub in the southern tier of upstate New York, and the Technical Assistance Voucher Program is one of several programs designed to support this ecosystem building endeavor. If you would like more information on New Energy New York, you can scan the QR code to access our website, and Samantha Lane will also be putting the New Energy New York website in the chat. Now let's talk about the NENY Technical Assistance Voucher Program. So this program, in partnership with New York Battery and Energy Storage Technology Consortium, or New York BEST, is also powered by Binghamton University, is designed to catalyze technology developments and the scale-up efforts for battery and energy storage startups and small to medium-sized companies in upstate New York. So we are hosting this webinar and subsequent office hours as part of our open RFP period for the second round of the Technical Assistance Voucher Program. During this presentation, we'll cover the program's purpose, the applicant eligibility criteria, award tracks, service provider qualifications, important dates and project timeframe, components of the application, matching requirements, and application logistics. Additionally, everything we're covering here today will also be located in the RFP, request for proposal, and will feature presentations from our key partnering service providers. As previously mentioned, the second round of Technical Assistance Voucher Program, this is the second round of the Technical Assistance Voucher Program. In the voucher program, eligible companies can receive financial support to cover costs associated with using shared services and facilities in New York State. In the first round of this highly competitive program, New Energy New York received 33 applications with a cumulative proposed projects nearing 4 million, showcasing the vibrant innovation and demand within the state's energy storage sector. After rigorous evaluation by a 12 reviewer panel, 6 outstanding companies were selected to share close to $500,000 in awards. This funding supported the development, prototyping, testing, and certification services to advance the commercialization and manufacturing readiness of their technologies. In round 2 of this competitive program, we will have the same program objectives and 2 separate funding tracks. Track A is for startup companies who can receive up to $75,000, and we will talk more about what defines a startup company in subsequent slides. And track B is for small to medium-sized companies who can receive up to $100,000. Companies will self-select their funding track during the application process, and again, we'll go into more about those separate funding tracks in subsequent slides. So to be eligible for the program, companies must focus on battery or energy storage technologies with a preference for those in the battery sector. However, technologies across the entire value chain are eligible to apply. The companies must have a physical presence in New York State, defined by any of the following bullets. So primary headquarters or principal place of business, manufacturing facility, research and development facility or location, and can be within a New York State incubator. Preference will be given to companies located in upstate New York and those who have an impact in the New Energy New York service region. Additionally, eligible companies must possess a unique entity identifier, SAM, or DUNS number, and have no more than 500 employees in the state. The companies will select their application track, as I previously mentioned, and they must also identify and engage a participating facility or for service provider as part of the application process. Proposals that include New York State-based minority and women-owned businesses are highly encouraged to apply. Let's talk a little bit about the company tracks. As I mentioned before, track A will be for startups who can apply for a maximum of $75,000. Startups will be defined as companies who have not raised more than $2 million in debt or equity funding from non-governmental sources and have been in business for less than 5 years at the time of the application deadline. Track B will be for small to medium-sized companies who can apply for a maximum of $100,000. And small to medium-sized companies will be defined as companies who have no more than 500 employees in the state and less than 5 million in product sales revenue attributable to the subject product or technology in the previous fiscal year. Again, to self-select your funding track, you simply indicate your funding request at the maximum for your track, or under the maximum, but definitely not over. And your eligibility criteria will be reviewed during the evaluation process. Okay, so let's talk about service provider qualifications. Eligible service providers include, but are not limited to, New Energy New York approved facilities and service providers. These can include Best Test Commercialization Center, the RIT Battery Development Center, Prototyping and Testing Services, Binghamton University Nexus Dry Room, Binghamton University Analytical and Diagnostic Lab, Intertech Portland Battery Lab, Cornell Nanoscale Science and Technology Facility, Center for Regional Economic Advancement, Cornell High Energy Synchrotron Source CHESS at the Cornell Laboratory for Accelerator-Based Sciences and Education class, Cornell Center for Material Research, and Stony Brook Center for Integrated Electric Energy Systems. But again, that is not the full list, but some other key service providers. Prototyping and testing facilities at 2 to 4 year college or universities, public, state, or nonprofits located in New York State, including centers of excellence and centers for advanced technology. Federal laboratory facilities, for-profit testing or certification service providers, other research and development prototyping facilities on a fee for service basis. Additional service providers can be found in the New Energy New York and New York Best Supply Chain Database, which you can access by scanning the QR code on this slide. And Sam is also going to put Supply Chain Database website in the chat. Proposals utilizing New York State-based service providers and facilities will be prioritized. Okay, so award vouchers. Eligible applicants can receive vouchers of $2,500 to $100,000 to defray the costs associated with services for the development of battery and energy storage technologies at qualifying facilities. Again, included but not limited to lab and commercial scale prototyping services, testing services, certification services, pilot scale non-commercial contract manufacturing services. All requests must specifically describe how requested services will advance the development of commercialization readiness of the applicant's battery or energy storage technology. Manufacturing services for sale of commercial use are not eligible under this opportunity. Requests should be feasible and aligned with the scope of work, as opposed to just maxing out the total available funding. Your budget should align with your scope of work and make sense in the program period. Vouchers must be utilized within 6 months of signing the voucher agreement, unless a longer term is approved by the program administrator at the time of award and agreement signing. Any unused approved voucher amounts will be canceled after a 6-month period and returned to the voucher program for future use. The program at the administrator's sole discretion, one-time extensions of up to 3 months may be approved if requested in writing, and we can go through this at our midterm meetings, which we'll get into later. So let's talk about the application. Here's an example on the right side of the screen of the application form to gather general company information. Applicants will also be asked to upload a letter indicating that the company has contacted and engaged with the respective service provider and facility, and that the facility has the capacity to provide the respective service and support the proposed scope of work. Applicants will also be asked to upload a service provider quote. We recommend reaching out to the service providers early along in the process. Additionally, applicants will be asked to upload a proposal narrative to include an executive summary or abstract, a company overview, a technology overview, including current and proposed TRL, the commercialization potential, as well as details of the proposed project, including a timeline and scope of work. Lastly, companies will need to submit a budget with the provided template. Budgets should be feasible and again, aligned with the scope of work. Eligible applicants can apply for a single voucher award per round, and voucher award funds will be dispersed directly to the service provider or testing facility through a detailed invoice submitted to the program administrator for services rendered to the awarded company. This will be uploaded through a similar form that you see at the side of the screen after the contract execution period. There will be match requirements dependent upon full-time employees. So if you see this chart on the screen, which is also listed in the RFP, you will there will be no match requirement for companies that have 1 to 5 FTEs, but applicants must provide evidence of leveraged resources, which can be staff time and equipment. 6 to 20 is a minimum of 10% cash, 20 to 50, minimum 25% cash, and 51 to 500 is a minimum 50% cash match for the total project costs. And again, this chart is listed on the RFP. The application process. So the next step after we complete our webinar is to begin your application. Sam will put the link to the application page in the chat, and it will also be emailed out to you in the follow-up email that you receive with the slide deck and recording of this presentation. Then you're welcome to email me if you would like to attend any one of the group office hours to get more specific questions answered. And those dates and times are listed on the screen. Those will also be in your follow-up email. Applications are due by 5 p.m. ET on August 30th. Late applications will not be accepted. This is a competitive process and everyone must meet the application deadline. Applications will be judged by a panel of individuals from across academia, tech innovation, economic development, and other technical experts, and we anticipate announcing awards in the fall. Once applications are awarded, they will be required to attend a kickoff meeting with myself as the program administrator and their service provider. Once that meeting has been completed, the program administrator will work with the awardees to execute funding contracts. That'll be me. I'll reach out and get a variety of information to include in your contracts, and we'll get everything signed and good to go. Once contracts are executed, companies can begin submitting their invoices that are provided to them by their service providers and uploaded to the New Energy New York voucher invoice submission page. And you'll be provided to that with that at that time. During the invoice submission process, you'll be asked to indicate the milestones that you have achieved and the match amount that was spent during this time frame. Please note, invoices should have a breakdown between what is being requested of the voucher program and your match amount, so that it is clear to our accounting departments what should be paid to the service providers. There will also be a midterm progress meeting with the program administrator, which is myself, to determine if there's any outstanding needs, celebrate successes, mitigate any challenges in the middle of the program, and provide programmatic feedback. A final report will be required once the project has been completed. All voucher awardees must annually report economic impact data to New Energy New York upon the completion of the project for a period of 3 years from the date of the voucher agreement. So please keep track of all this information once you've completed your project. I do recommend reading the RFP fully and completely. Everything that we've talked about here is listed in the RFP, but please reread it multiple times, highlight the document, print it out, keep it close so that you don't miss anything. And of course, if you have any questions during the application phase, please reach out to me. My email has been all over all of these emails that you've been getting about registering for the program and will be in the follow-up email as well. I'm here to help. And at this point, I would like to turn it over to some of our service providers. So first, I'd like to, again, introduce Matt Cantor and Martin Ploss of the Battery Development Center at RIT. So I'm going to stop sharing and I will give these two gentlemen the capacity to share.
All right, thanks, Emily. Share my presentation. Can everybody see that? Good. Thanks for the thumbs up. And yeah, Emily's been fantastic to work with for the first voucher phase. We had a couple of voucher programs there, so please don't be scared to reach out to her for any questions because she is a wealth of knowledge for this program. And thank you for the opportunity to speak about our center as one of the approved service providers through this New Energy New York voucher program. Martin Ploss and I are going to be presenting this jointly. Martin, are you on? Check. Is it? I believe. Yes, yeah. There you are. I just want to check your volume is working. All right. So since we are now a combined center, as of April 1st, we have combined resources between under RIT, both prototyping and testing resources. So Emily mentioned the development center, I think, and the best test and commercialization center, but actually that best test and commercialization center is under RIT now. So we are managing both the battery prototyping center on campus, which is going to be expanding to 5,500 square feet in the near future. And then we, as of April 1st, are operating the best test and commercialization center on Kodak Park, which can offer testing services from the cell level all the way to the systems level. For the prototyping center on RIT's campus, we're able to build lithium-ion batteries from scratch or other chemistries as well. Fabricate electrodes and build pouch and cylindrical cells. But this new overarching battery development center really brings together all these resources under one entity under RIT, where you're able to go from materials all the way through certified testing. And Martin's going to talk about the testing capabilities in a little bit. So this has a lot of slides in this presentation. We wanted to make these available because the slides are going to get sent out, but we're going to move through these relatively quickly. So there's enough time for all the other great facilities to speak about their capabilities. But on campus here for prototyping services that we offer, we currently have 1,000 square foot dry room, which has all the resources to make your commercial quality lithium ion cell battery from scratch. In both pouch and cylindrical formats. We have roll-to-roll slot die coating capabilities, 1 to 2 liter mixing capabilities, calendaring, coating, slitting, everything that you need to make your standard electrode. We keep a lot of standard lithium-ion materials in-house that are available for testing your new material against a kind of a commercial material and seeing what the comparison is there. And we worked with at this point, we've worked almost 100 different companies and collaborators for the prototyping work. Just a few project examples here for the prototyping center. We do material screening for companies that are looking at developing new materials. Sometimes they're for the company that's developing the materials themselves, or sometimes it's for the end user. So in one case, we had an automotive company that was interested in a new silicon material from a startup company, but they didn't have the capacity to test that material in-house. So they contracted with us to do coatings and batches of cells so that we could provide a third-party reference for the performance of this new material. In other cases, with a lot of the local companies and startups, we actually can be the facility can be utilized as a user facility. So companies can have their employees come into our dry room and use our equipment, get trained on how to make electrodes and cells, and actually have their staff operate the equipment and perform their project and perform their work. And the next few slides just go into a little bit more detail on the equipment that's available. Again, 1 to 2 liter batch sizes for slurry mixing. So we're kind of in that in between the lab scale and the pilot scale. Full roll-to-roll coating capabilities. We'll be adding even more coating capabilities in the next year. And then calendaring in order to compress and finish your electrodes, roll-to-roll heated calendaring. And then for cell fabrication, we tried to automate every single fabricate every type of form factor and automate every single manufacturing process. So even down to the coin cell level, we have automated coin cell manufacturing. If you're at the very early stages and you need to trust those early cells that you're producing and that you're getting good data, we have a machine that will automatically pick and place and build those cells. And then semi-automated lines for pouch cell and cylindrical cell fabrication. For the pouch, we can go up to 25 amp hour cells. So we can go from very small cell phone size to larger kind of EV formats. And then on the cylindrical cell side, we can make 18650s, 2170s, which is Tesla's format, and 26650s. So really, not many universities or facilities that have this kind of automation and are able to make both pouch and cylindrical cells in-house. And once you have finished finalizing building your cells, we're also able to do certified third-party testing and some safety testing, which I'll hand it off now, and Martin can give some details on our testing capabilities that are now under RIT.
Yeah, thank you very much, Matt. Hello, everyone. Martin Plus. I've been with the test lab for the last 4 years or so. Before under DNV and now under RIT, and very happy to have this combined power together with the prototyping lab at RIT and be able to offer our services here to the group in the NENY voucher program. So we have a lot of experience in testing. And Matt, if you don't mind advancing the slide.
Yep.
We go essentially do the next step. So cells that Matt has made, we can test both for safety and performance. But we also work with a lot of companies at a larger, further stage in the cell development to validate cells, to look at long-term degradation, look at also system performance. We are totally agnostic to cell types and chemistries, so we can test any kind of cylindrical pouch or prismatic cells, really up to about 500 amp hour cells. We see a lot of these large LFP cells right now, but also the new large scale can type cylindrical cells, and we can handle it all. You go to the next slide, please. So we really focus at the test lab in 3 areas. So the first one is life cycle and degradation testing. So where we can essentially take cells and run them through cycle tests to characterize the performance, and then also cycle them for an extended time period of 3, 6 months, a year, however long, under different conditions, at temperature, at different C rates in climate chambers and so on, to really understand how the cells degrade over time and how they perform over time. Then the second area is where we do the system testing. So we don't just look at one battery cell, but we look at the system as a whole. So the battery storage system we've essentially developed a validation program for residential energy storage systems that are where you have the battery with the BMS, with the controls, often the inverter that can also control PV. And we can simulate all kinds of operating conditions to really test the system as a whole and see if it functions under all operating conditions, and also if it's fail-safe. And then the last area, that's really looking at the safety of battery cells. And we can do the JUL 9548 test, and we can abuse the cells in different ways to determine that. If you go to the next slide, a little bit more detail. So here on the cell performance testing, we have 650 cycler channels, and we have all sizes. Most of them, of course, are cell level cyclers, but we also have module and pack level testers up to 240 kilowatt, 1000 volt, 500 amp. And we have, of course, climate chambers to go with that. And do different studies. For example, on the modules, we can add different temperature probes and measure the cell voltage on each cell to really understand the thermal behavior inside the module while it's being cycled. And then obviously on the pack level, you're looking also similar to the system, you're looking at the pack as a whole. Next slide, please. So here's an example of cell degradation where we tested 4 cells under the same test conditions, and it clearly shows, I mean, 2 cells degraded as expected on the slide, decline there very slowly, but then 2 cells did okay in the beginning, but then at around 800 cycles, they totally tanked. And that's something obviously that you want to know if you try to sell these cells in the marketplace or if you're integrating the cells. So we can certainly look at that and find that out. Next slide, please. So here's an example of the system testing. So you see one of these residential storage systems in the climate chamber here, and we look at really kind of checks through the system for everything. It's almost like a complete physical for a system to both verify manufacturer specs, but also look at the behavior under more extreme conditions at extreme temperatures and so on. Next slide, please. Here's our safety test room. So you can see here where we have on the left side, we have the nail penetration device inside a hood. This room is specially designed with a very high exhaust flow rate so that there's no dangerous buildup of combustible gases in there. And then on the right side, you see that pressure vessel that we use to conduct the JUL 9540A cell level testing, where we typically take a cell, heat it up, and collect the gas. And we can also do overcharge and short circuit testing on these cells. This is very useful, often, especially the nail pen for like on prototype cells to kind of try to characterize initial behavior in some runaway or short circuit situations and be able to compare that to other cells. Next slide, please. Here's a few pictures of examples of testing. On the left side, you see a cell wrapped with thin film heaters in preparation for an overheat test. Middle picture, you see the nail penetration test in action. And then on the right side, you see a short circuit cell test. So all these tests designed to either show thermal runaway, produce thermal runaway, or show that a cell is not susceptible to thermal runaway. So if you have a cell that doesn't go into thermal runaway, we run it through these different abuse methods and show that it actually is cannot be triggered. Next slide, please. Yeah, here's a typical example of the safety test for JUL 9540A, where we heat the cell and you see that steady incline in the temperatures in the left chart there with some venting where the temperature drops after a certain time, and then at some point it goes into the thermal runaway with this very strong exothermic reaction. On the right side is gas production, so the vent gas production. We do these tests under inert environment, so there's not any combustion inside the cell or the pressure chamber. So we get the pure vent gas, and then we can take the vent gas and send it off to be analyzed. Next slide, please. So here's an example. So this is how we collect the vent gas, and then we send it off for analysis, and then we get a composition of the gas with the components, and we also know the volume of the gas that was produced by a cell, and that's very important input information to do any kind of simulation studies for safety. Next slide, please. Oh, that's it. So yeah, we'd be happy to work with you. One last quick thing. I'm going on vacation end of on the 8th of August. So I'll be gone for 2 weeks. So any kind of proposals you need for testing, please try to get those to me the request very soon so we can get you quotes for this. Thank you.
Great. Thank you, Martin. Thank you, Matt. Yeah, as Martin was saying, the sooner you can reach out to the service providers, the better. So now I'd like to turn it over to our next presenter, Hugh Zhu of BU's Nexus Dry Room. Hugh Zhu?
Okay, I share my screen now, right?
Yes, you should be able to share your screen.
See my screen? Okay. So, good on. My name is Hui Zhou. I'm Nexus Dry Room battery facility manager, and I'm very glad to involve the round 2 voucher program. So for Nexus is the research center for the as explained here, Nexus is the research center to understand how the key electrode reaction happen and how they can be controlled and improve the electrical performance from the atomic level to the microscope level. And even the operation of batteries. Professor Ham is our director. So the Nexus Dry Room and battery facility is ready to service since the December 2018. It is designed to be an open user facility, try to provide the researchers from both academia and also the industry the state-of-art lab environment for lithium batteries research development and manufacturing, even the testings. So we have a dry room for about the size is about 600 square feet, which allows 4 people to be operating at the same time, and and that to community about less than 0.5%. So which equipped with the full polycell assembling facilities, so we can provide help you to fabricate high quality coin cells and even the prototype polycells with the industrial production environment standard. So normally we will have the NDA with all the users, and we allow the users completely maintain their IP and accept some co-funded research project. And presently, we made for the outside user main works through the daily pay for service rate, and roughly we it's about 1,500 per day, or we charge by whole day or the half day. So we also maybe it's possible for research collaboration for the ground applications. And because we are partner with Nexus and Buchanan University, so it's also we provide the unique opportunity to collaborate with on campus or other PI in our universities. So this slide lists all our facilities for the electrode fabrication and also the cell assembling process, cell assembling facilities. So on the top is mainly for the coin cell facilities. We have the 2 small mixer, the sinking mixer, and also the FlexTech speed mixer, which can have different container size from about 12 millimeter to about 300 millimeter. So then this can help us to prepare scenario for different amount, and which is enough for the small scale coating for the coin cell making. And we may use the Hausen 2032 coin cell pass for the coin cell test. And below that one is our we have the polycell facility include which can take care of every step needed for the polycell making, since from the start mixing to coating and then carrying until the fellow sealing, welding, and polycell making. So presently, we have 2 scenario mixing machine. Everyone has each one has about 6 liter volumes, and they all connect to the vacuum pump and also the tinner for the degassing and the temperature mixing control. And our coater is reverse coma row-to-row coating, and which can give the coating width about 200 millimeter, and the coating speed can go up to 3.5 meter per minute. And we have 2 drying zone with 1 meter for each, and can go up to about 150 degrees Celsius. And the kinder machine is can go up to with up to 140 bar, and maximum heating can go up to 150 degrees Celsius. And we also have the punch machine. The punch machine is based on this cell design. Presently, the size for the cathode is about 83 times 98 millimeter, and anode is 85 times 100. Also have some other machine for like zigzag stacking, welding, fanning, and sealing. And after that one, we have degassing and the sealing machine. So besides the small, besides the big mixer, actually these two small mixer, sometimes we also use that one, use a maximum container for some moisture sensitive scenario making. Just like, for example, when we also use this small mixer to mix nickel-rich MCI custom material to get a scenario about 200 to 300 gram, and that one can give us about 2 to 3 meters non-coating. It's also work for the small or single layer polycell or small capacitive polycell makings. So present for polycell, and we have the double cup formation machine, so that can give us the stacking thickness up to 13 to 14 millimeters. So that means we can make the cell with about totally a maximum 40 to 15 layer about actually inside the polycell. And besides all the cell making facility, we also can do some cell formation or testing things. Presently, we have about 250 secular channels for the current cell test. The current can go up to 1 ampere.
Yuzu,
yeah.
Yuzu, we're only seeing the slide 1. I'm not sure if you're trying to advance to the other slides.
Oh, I go to this one. You didn't see?
No, we hadn't seen that one yet.
Now it's second slide on first one.
Okay. Yeah, we were only seeing the first slide, just letting you know.
Oh, how about now?
Yep, great.
Oh, this one just, all right. Should I go again, or I can go to the next slide?
Oh, you can go to the next one. That's fine. Thank you.
Okay. So besides the battery facility, and we also have some circulars for the cell formation and testing. And for example, we have about 250 circular channels for the console, can go up to 1 ampere. And we also have 200 circulars for the polycells. The current can go up to about 12 ampere. And besides that one, we have about around 25 biological gas channels if you need the impedance measurement. And we have 2 temperature control chambers. This can control the temperature from the -20 to 180 degrees Celsius. It's especially for some project you need the temperature control for the test. And also for the high capacity polycell, we need this kind of oven for safety consideration. And if we also provide some calculations, if the user need or the customer needs some research completely on the material level. For example, we have the actual machine in our lab, and two extra machines. One is for the powder diffraction for the phase check. Another one we can do it's just like shown here. We can do some small polycell and then do some random XRD to do the structure study for the materials, cathode or anode, and during the cell running to check the structure during the cell cycling. Because another thing that one, because our present project is do a lot of summer studies things, so we have some med equipment to do some operando summer monitor to check either the coin cell or during the polycell, what's the heat release produced during the charge process. And we also have for this module, we also have the ARC modules that can provide to check about the self-heating rate and also monitor the summer runway reactions, which can go up to temperature about 500 degrees Celsius and pressure can go up to 150 bar. So if you have any need for the battery making or testing or other research collaboration, you can contact me. And this here my email and phone number also. You can go to our website to see on our website there is short videos for each polycell equipment. You can see that can give you a simple introduction for each equipment how they are work. And our location is about on site about the Binghamton University campus, and is physical facility is shown here, and our building is the Center of Excellence building in at ITC. Thank you.
Thanks, Yuzu. That was great. We appreciate it. And sorry that I didn't notice that the slides were in advancing until a little later, but that was helpful. Okay, so now I'd like to turn it over to our next presenter, Donna Howell of the Cornell Center for Material Sciences. Donna?
All right. Can everyone see my screen? Am I all good? Awesome. All right, so I want to give a little background about CCMR just because I think we have a pretty cool history. So we kind of grew out of post-World War II and Cold War era scientific research. We were first established in 1960 as one of the first 3 original federal material science research centers. And today we kind of have these like 3 legs of the stool. We have world-class research. We have our industry programs, and then what I'm going to be talking about today are our facilities. So we have a world-class shared facility with equipment and staff experts that can support your industrial R&D efforts. And this is really great because I know a lot of small companies or startups don't really have a lot of capital to invest in major R&D operations. And so the benefit of centers like CCMR is that you can come and just pay per use without having that big operation in-house. So we have the 10 experts here. Newest is Sean Donlan, who just came on board a couple months ago as a glass blower. We haven't had that in a few years, so we have reopened our glass shop for scientific glass blowing. And we have, in addition to our 10 staff members, over 120 faculty members. And this is across multiple disciplines, and that's what really makes our material science center so robust, is that we have folks from chemistry, from physics, who work on projects together. And we span, I think, 12 departments over 4 colleges here at Cornell. So the facilities that we have are broad. I'm not going to go through every single one of them, but I will give you some general information and then how you can get more information or on a specific tool if you're interested. All right, so we have some film deposition and materials processing. So let's say you have a project where you wanted to make materials or a device. You could come here and deposit films and process them using deposition tools and furnaces. I think, you're going to hear from CNF in a minute, but they have some of these as well. You could take that same material and then determine if the processed films have the desired compositions and structures using XPS or X-ray diffraction to characterize films. And after that, you could go to CNF to pattern the films to make devices. This is our fabrication center here on campus. Come back to CCMR and then perform measurements in PPMS characterization systems. You could also learn about electronic and magnetic behavior when subjecting those to various temperatures and magnetic fields. And then you can also use our electron microscopes to look more closely at the material and see what's happening at that atomic scale. So if a picture is worth 1,000 words, we have some of the highest resolution images that have been generated from our microscopes. A fun fact is that we hold a Guinness Book of World Record title for the highest resolution microscope. And this is a microscope that depicted individual atoms at about 20 picometers resolution. And so that was like in 2019. So we've done a lot in the past 5 years. And then we also have some of our mechanical properties testing and analysis equipment. And we can also do soft matter or polymer analysis as well. And then we have our surface analysis and characterization equipment. So I think most importantly for the folks on this webinar is if you are interested in becoming a user. So we're happy to provide the cost service quote as well as a letter for your application, but generally speaking, everyone has to sign up to become a user. online using our facilities online manager or FOM system. It's very easy. I've put both the website here as well as a QR code if you just want to take a picture of it. Or you can just go to our website and go to becoming a CCMR facility user. You'll fill out an online form, and then depending on the, you have to do some basic training and orientation generally for CCMR, and then depending on the tool that you want to use, they may have additional training requirements. And so our staff here can provide that training for you. They can also help you with using the instruments. You can either use the instruments yourself. Once you're trained, we essentially give you the keys to the car. You can just reserve time, and then you can access it on a weekend or evening or whatever fits your schedule. Or if you need a little bit more support and assistance, we can do service work where our staff would actually do the work for you and then provide you with those results. And so this slide just shows a few other facilities here on campus. You're about to hear from Ron, my friend over at CNF, but in addition, we have Chess and Paradigm. These are all shared research facilities, and they are world-class centers, and they have expertise and kind of first-in-class equipment. So, you know, coming to CCMR, you are also connected with these other centers and vice versa. And we are not just here to provide the tools. We actually have the staff with the expertise to help you on a project or figure out what tool might be best to use for your specific needs. So I've got my contact information here. I also shared a flyer with Emily to share with anybody who's interested. All this information is on that as well. But if you remember nothing else, just remember you can reach out to us via phone or email, and we can kind of walk you through all of this. And that's it.
Great. Thanks, Donna. It's good to see you again. All right, and I'll now hand it over to Ron Olson at Cornell's Nanoscale facility. Ron?
Thank you. I think that's not what I want to share. Let's see. Okay. Okay, can you see my slide? Yes, okay, thanks. Okay, so my name is Ron Olson, and I am the Director of Operations at the Cornell Nanoscale facility. It's also known as CNF, so you'll hear that throughout the talk as well. So CNF is a world-class open user facility for micro and nano fabrication, and we assist users from across the country and across the world. So projects that come to our facility range from pure university research all the way from product development and prototyping for both large and small companies. CNF has really developed, just like CCMR, developed a really effective way, a streamlined process to gain entry to our facility. So in most cases, a project can be reviewed, screened, and improved within 2 weeks of initial contacting us. So additional information is available at our website under Start a New Project. You can see there on the far left. All you have to do is click that button, download a few forms, contact our user program managers, and start going. So CNF, we have a 17,000 square foot. It's a class 1,000 clean room space. We have over 180 tools. I think we have close to, and these are major tools, just not like all the extra metrology tools and stuff like that. Over 180 advanced fabrication, as well as characterization tools. The QR code that you see there will take you on a virtual tour of our clean room. So you can actually, you know, just go into the clean room just by clicking that QR code, and you'll be able to see each equipment. There's little red tabs and green tabs on the equipment, and it'll tell you the specific materials in it, as well as what the machine does, and so forth. So the most important asset I think that CNF has is the great staff that we have, just like Donna was talking about her staff. And the staff's main objective here is to support our users. We provide process engineering advice. We provide individual training. Since we are a user facility, we do train all the individual users on how to use the tools. And then Our staff also maintains all the equipment. So just like Donna was mentioning, we also have other avenues where we have remote capability where the staff will jump in and do the work as well, and other contractors that you can find out on our webpage that is able to do work inside of our clean room as well. Okay. We have a very comprehensive set of equipment, and if I started to go through all the equipment, we'd be here for hours. But it really provides start to finish fabrication for your devices, including we have software simulation, we have back-end processing capability, and packaging, as well as high frequency testing as well. We have an advanced, one of the things that CNF's really known for is their advanced lithography suite. And it's anchored by, we have 2 e-beam systems and a ASML deep UV stepper, 2 in-house mask makers. So you can actually come to our facility and make masks for your wafers as well as contact aligners. Okay, so we also have a partnership with biotech and mechanical engineering, along just like what Donna said with Paradigm, CCMR, and Chess. We also have partnerships with biotech, mechanical engineering's rapid prototyping lab, which really provides our users additional advanced 3D characterization and imaging tools and additional 3D printing capabilities. So we can process a wide range of materials. We actually have like 5 different categories of materials without cross-contamination, as well as different wafer sizes. So people can do small, which we call pieces, all the way up to 200, and even some cases 300 millimeter size wafers and substrates. So recently, through the Microelectronics Commons, CNF is upgrading its equipment. So we're getting an additional $8.2 million worth of equipment. And this equipment's really going to, kind of more modernize the instruments that we have. And it's really specifically also to support quantum materials, head integration, and our 200 millimeter capability. So last year we had over 1,000 users. Actually, I think the number was around 1,300 or so users that come to our facility from all over the country. On average, I think it's about 400 per month. And we really have an effective ecosystem for both research and technology commercialization. So since like 2015 is when we started joining the NNCI, we've worked with over 171 different companies, including like 127 smaller startup companies, as well as 44. Each one of these companies really use CNF for its major innovation activities. And we realize about 2 new startup companies, 2.5 companies per year who come to use our facility to really launch their companies. So CNF also supports a broad range of education and outreach activities as well. So this past year, meaning 2023, I think we had 116 different events with over 454 different visitors. This includes like Micron chip camps that we had, research experience for undergraduates, and international research program as well, in various collaborations and programs, micro-credentials with our local community college, which is TC3 up in our area, as well as local programs, which you see up there on the screen called Atlas, with our local BOCES areas, as well as we taught them how to do high purity welding as well. So thank you, and we look forward to working with everyone. I do have to mention that I will be on vacation August 13th through the 18th. So I like that comment earlier. So please, if you're interested, reach out, and we have regular tech sessions every week with the staff. If you want to talk to them about different, materials or technologies or how to do things, please reach out as soon as possible. Thanks.
Thanks, Ron. Yeah, it's that time of the year, isn't it? Okay, so we don't have a lot of time left, and I want to make sure there's opportunity to finish the presentation, and we'll do some question and answer. If people want to stay on for that, they're more than welcome. But we have a last minute addition. So David Hamilton, who is the director of the Ecosystem Growth and Impact at Stony Brook University. David, would you like to say a couple of words?
Sure. Thank you very much for giving me a couple seconds. Hi, everybody. I have no slides. I'm coming in at the end. The resources you just heard about are phenomenal. You should access all of them as much as you can across the state. So I'm Dave Hamilton, Director of Ecosystem Growth and Impact at Stony Brook University. I am also the Interim Center Director of Center of Advanced Technology down here called CEAS, the Center for Integrated Electric Energy Systems. And so CEAS, as a CAT, is looking to collaborate with New York State industry companies. We're looking to make an impact, drive economic impact across the state, and take companies and help push them forward, as long as everybody else that you've heard. So as a CAT, we're looking to do projects with New York State companies. And in case you didn't gather from the name, we focus on technologies that are integrated to the electric grid. So that's JUL. So we're a little bit different than some of the other services and facilities you've heard about. We're kind of at a system level. So we look at modeling, testing and validation, small site demonstrations. We do a lot of relationship building between the utilities and the startup companies and help to drive demonstration projects, pilot projects with them. We have test beds here at Stony Brook, similar to some of the amazing stuff you heard. We have a microscopy suite. We have a microgrid, we have a high voltage lab, and we're building out a couple other test facilities as well. We have some pretty significant battery and energy storage research facilities run by Dr. Esther Takeuchi. And we also have access to Brookhaven National Lab down the street from us. Most of our researchers here at Stony Brook are really joint hires with Brookhaven National Lab. So I know I only have a couple seconds. So at the end of the day, I'll put the information about.
David, you muted yourself.
See, that's what I do when I get so I just put my center in the chat. Reach out to us. I am not going on vacation over the next couple of weeks, so I will be available to you. Love to talk to learn about your company. Love to talk and learn about where your wants and needs may be and how our center can help you move forward in any way, shape, or form. We do have a Center of Excellence, which is behind me in advanced energy. I'm sitting in a Center of Excellence for wireless and IT, so we also look at data, AI, cybersecurity, stuff like that. So a lot of stuff happening in Stony Brook. Thank you for the opportunity. Sorry for talking very quickly. Looking forward to hearing from you.
Thanks, David. Okay, just going to do a couple more slides and then we'll have opportunity for questions. Okay, can everyone see that one slide about the other NENY opportunities? Just give me a thumbs up. Great. Okay, so for those that don't know, we also have programs that are listed here. So the supply chain or the battery supply chain database is a database hosted by New York Best, which is a comprehensive database of companies that are engaged in producing materials, components, and subassemblies and or performing services in support of production of batteries, battery modules, and packs and energy storage systems. That information is available through that QR code. You can access the supply chain database by scanning that. Sam's going to also drop that into the chat. We also have a paid student internships through our Student Startup Experience program. This program provides paid opportunities for undergraduate and graduate students to work with high-tech startups in clean energy and energy tech fields. So the internships can be in person, remote, hybrid options for graduate and undergraduate students from various disciplines. So that might be useful for some of your companies to get some interns to work with you and also help develop those young minds as they're getting into the field. We also have the Battery Academy, which provides technician and expert training through flexible learning platforms for battery workforce training in New York State. The Battery Academy offers stackable micro-credentialing programs to propel individuals their career goals in the battery sector. And that has been receiving a lot of praise and is really doing fantastic. A lot of people are moving through the program and posting those credentials online. So it's a really great opportunity. And lastly, we have the Charge Up Battery Startup Accelerator through the Kauffman Southern Tier Clean Energy Incubator associated with Binghamton University. And this Charge Up is a 6-month accelerator program that supports startups developing emerging solutions in the battery and energy storage space across the entire value chain by advancing their technology commercialization and investor readiness. Companies accepted into the Charter program will receive $25,000 mentorship from esteemed technical experts, investment opportunities, access to state-of-the-art facilities and resources. So that's a little bit about those other new energy New York opportunities. The information is up here on the slides, and I think we had a couple of questions in the chat that I wanted to bring up. And so now is an opportunity for those questions. I also wanted to just say a quick thank you to all of our presenters, Matt Ganter, Martin Ploss, Donna Howell, Ron Olson, and David Hamilton for coming on to the presentation and talking about their fantastic facilities today. So one of the questions that we did have in the chat that I wanted to bring up, and this is specifically for RIT and Nexus, is somebody was asking about the vacuum sealing. They wanted to know more details. Do you have the capacity to do vacuum and sealing for prismatic?
For RT, no prismatic. Pouch, we can fill under vacuum and seal under vacuum, as well as degas. For cylindrical, we don't fill under vacuum. Well, we initially inject not under vacuum, but we do soak in vacuum and pressurized gas before crimping.
Okay.
Same for Nexus, our vacuum and sealing is just for the polycell, not for prismatic.
Okay, thank you. Thank you, Matt, and thank you, Huzu. We had another question. Sergio, I see your hand is up.
Yeah, I have a question for you, Emily. We are prior applicants to the program, and since this is quite expensive for a startup, because you have to do all these arrangements with the providers and letters, etc. So it's a lengthy process for us. So I would like if you can tell us what are the metrics for this competitive program, because we apply, but we do not know how it's evaluated. So what are the metrics of the evaluation?
I can answer that question offline through an email, but just so you know, like I said, in the first round, we received 33 applications totaling over 4 million and only had around 500,000 to award. So it is a very competitive process, judged by various panelists. They're judging against the scope of the work, the quality of the project as it aligns to the project objectives, the ability to what the judges feel to meet those expectations, or sorry, to the judges feel the companies can meet those requirements. But I can definitely share more information around the evaluation criteria with you on an email, and if anybody wants that information, we can definitely share that out.
Okay, thank you.
Yep. Let's see. Any other questions? I don't think there are any other. Oh, Martin has a question. Martin?
Yeah, I just wanted to mention with additional resources, we at RIT, we also do this 2-day battery training seminar that's been very well received. That's also funded by New Energy New York. I think there's one coming up in September and another one in December. So that might be also a nice resource for people in this group here.
Registration is currently open September 19th and 20th. Is when it'll be held.
Thanks, Mike.
You can find the link on the website, our website, in the chat under the NENY seminar.
And before I jump into that, Sergio, one more thing I wanted to mention too, if you'd like to have a discussion before you even begin your application on any sort of feedback on the previous application that might help you to maybe address some of the drawbacks, if there are any. Like I said, I'm not sure exactly what that was because I wasn't involved in the first round, but a typical method would be to reach out, if you are denied, and ask for feedback. So I can definitely provide that if there is any feedback to be given. So just wanted to bring that up as well. For people going into round 2, if you were to be denied, you could certainly reach out for feedback and we can discuss that.
Thank you.
And looks like Ron had his hand up. Ron, go for it.
Yeah, just one quick question. As far as the letters of support for the application from the facilities, what are you specifically looking for?
Oh, are you asking me, Ron?
Yes.
Oh, we just want to see that the companies have engaged with you and that you do have the capacity to meet the scope of work that they're proposing. So you just
Alright.
have it's essentially just an agreement saying, yes, we agree to do this. We are understanding of what's required.
All right, thank you.
Yep. Any other questions?
I mean, just to summarize, if I may, I mean, so for the application, so you need, so the company writes the application, writes a proposal with the budget and everything, but then the supplier, like us, it's a test lab or whoever, we provide a quote, so that would
Yes.
be attached, as well as a letter that we can do the work.
Yep, so the letter again just pretty much says that they've engaged with you, you know that this is happening. It's not going to be, you know, a company's awarded to work with you and you've never heard of them before, you didn't know this was even going to happen. So we need to know that what they're requesting makes sense for the scope of work. That's where the service provider quotes come in. And then the letter is just saying that they've made that engagement and that you are willing and able to support them in this project.
But that, it would say that in the quote anyway, so just.
Yes, but they have to be uploaded separately, so it's easier if
see.
you could provide two different documents.
Okay.
That makes
Understood.
sense, yes.
Sure.
Yeah. Any other questions about those logistic pieces? John, I saw you had a question about, is the competition for only for battery creators, you reuse batteries? I don't know the answer to that question, but I'm happy to get back to you about that. So, if you want to shoot me an email, I don't know if I had my email address in the presentation. But it is all over all of the emails you've been getting and right here in the chat.
Sent you my email in the chat.
Okay, great. Yep, and I shared my email as well. So as I said, you know, this is a competitive process. There are obviously quite a few people on this call, quite a few people that want to apply, and a limited pool of resources that we can give out. So anything that we can help you with, if you have specific questions, you're going through your application process and you're coming into issues, you can shoot me an email, you can sign up for one of the office hours. Again, that information will be in the follow-up thank you email. We're going to be holding one on Wednesday, August 14th from 11 to noon, and then another one on Tuesday, August 20th from 3 to 4 Eastern time. And that's just another opportunity for you to troubleshoot any issues with the application or ask any particular questions. And I know it is time consuming to submit these applications, but you just have to assess if that's something that you would like to pursue, and hopefully you will be competitive enough to be one of the awardees. We had 6 in the last round and they're doing great work, making strides, and I think almost all of them are going to reapply again, but as we mentioned earlier, we will you know, prioritize companies who have previously at least spent down the funds from round 1. So,
And how much money is available again for this round?
I'm not sure the answer to that question, Martin, but I can definitely get back to everyone and let them know. It's also out of different pots of money, I'm pretty sure. So some of it might be specific to location. So let me get back to you on that answer. I don't give you the wrong information. Anyone else have any questions? I know we are over time by about 10 minutes, but I wanted to give the opportunity. Okay, well, being that there are none, again, thank you so much for attending today. I really appreciate all the presenters taking their time to show us everything they can do in their facilities. And as they mentioned, you know, please reach out sooner rather than later for any of your needs. And we hope that you apply. A deadline is August 30th. So good luck and have a happy afternoon.